Alright, so this is a review of triangles and perpendicular bisectors. So perpendicular bisectors and triangles. You have a triangle ABC and a perpendicular bisector BD. Remember, the word perpendicular means 90 degrees. So since BD is a perpendicular bisector, it's going to create a 90-degree angle. And it bisects. Once again, bisects means cut in half. So that means the segment AD is going to be congruent to the segment CD. And since it's a perpendicular bisector, what it ends up doing, since the length of BD is congruent to itself, it has actually made two congruent triangles. So triangle ABD is exactly the same as triangle CBD. So when you have an angle, a perpendicular bisector in the triangle, it ends up creating two congruent triangles, which means that the side BC is the same length as the side AB. And therefore, you would know that angle A and angle C would be the same degrees. And the two angles up here, angle ABD, would be the same as angle CBD. Right here is also 90 degrees, because now that perpendicular bisector makes two congruent triangles when it cuts it in half. So we're going to use those properties to help us solve some problems. So for this one, it asks us to find the length of RS. Before we can find RS, we first have to figure out what X is. You'll notice that in the picture that RT cuts the triangle in half. You see your 90-degree angle, and these two pieces are congruent, which means that RT is a perpendicular bisector. Therefore, the triangle on the left is exactly the same as the triangle on the right. So that means this length right here, RS, is the same length as QR. So if those two sides of the triangle are the exact same length, we can set them equal to each other. 7x minus 22 equals 4x plus 5. You want to go ahead and solve the equation. So I want to get x on one side of the equation. Here's my equal sign. I'm going to take this 4x. I'm going to minus it across the equal sign over here underneath the 7. That's going to give me 3x minus 22 equals 5. I am then going to add the 22 over to the 5 because I want a term on the left side of the equation and the right side of the equation. That's going to give me 27. I bring down my 3x. I want to get x by itself by dividing by 3. And x equals 9. Now that I know what x is, now I can plug it back into the expression for RS. So RS's expression is 4x plus 5. And that x is actually a 9. So 4 times 9 is 36. You add 5, and you're going to get a length of 41 for RS. So problem 2 is asking us to find the length of AD. Once again, you'll notice that since CD is a line right here, notice it makes a 90-degree angle. And this time they let us know that BC and AC are congruent. When that happens, 90-degree angle and these two sides of the triangle are the same. The left triangle and the right triangle are exactly the same. Therefore, this length here is congruent to this length here because CD is a perpendicular bisector and it cuts this side in half. So it's two equal pieces. If they're equal, set them equal to each other and solve the equation. So I'm going to minus the 3x over to the 5x. That's going to get me a 2x. I'm going to add the 11x over to this, I'm going to add the 11 over to the 17. That's going to give me 28. I'm going to go ahead and divide by 2, and x is 14. Once again, it wants the length AD, so I'm going to take the expression for AD, and I'm going to go ahead and plug in the 14. So 14 times 5 is 70 minus 11. It's going to give us 59 for the length of AD. Angle bisectors. So this is a picture that has a pair of angle bisectors, which is right here. I'll mark this one in purple, and I'll mark this one in blue. They are the same length. AD is bisecting that angle, making the blue and the blue and purple angles congruent. If they are congruent, and these are 90 degrees, the sides opposite of them are going to be congruent to each other. There's always that relationship between the angle and its opposite side. All right, so for this one, we have angle bisectors. You'll notice that up here, this angle that I'm marking in purple and this angle that I'm marking in blue are congruent because they have the single congruent mark for angles. So since this angle up here has been cut in half, there is always that relationship between the angle and its opposite side. So if these two angles are the same degree as marked, then their opposite sides are also congruent. Therefore, these two pieces of the picture are congruent, and I can set them equal to each other and solve. I'm going to go ahead, I'm going to minus the 8x over to where the 13x is, and I'm going to get at 3, I'm going to get 5x. I'm going to add the 4 over to the 11 to get 15. Divide by 5, and x is 3. It wants to know the length of AD, so I'm going to plug it into that expression. So 13 times 3 minus 4. So 13 times 3 is 39. Minus 4 is 35 for AD. All right, so still dealing with angle bisectors. They're showing us that this length right here is congruent to this one, and we've got 90 degrees here and here, which lets us know that ZW bisects the angle up here in green and the angle down here in orange. If that angle gets bisected into two pieces, remember bisect means to cut it equally, they equal each other. And so now you just solve the equation. I'm going to minus my 3x over. I'm going to get 5x. I'm going to add the 3x over. Sorry, I'm going to add the 32 over. I'm going to get 35 equals 5x. Divide by 5. X is 7. And since they want angle mxWZ, they're talking about this one that you need to plug into. So the measure of xWZ is 8x minus 32, and our x is 7. So 8 times 7 is 56, minus 32 is going to be 24 degrees for the measure of that angle.